I'll go back to share my screen. So once again, you are welcome. Please, whenever you have issue, let me know. Everybody is unmuted. Only I don't want noise, but you're unmuted so that you can speak and I'll hear and know what your challenge is. Okay. Now, because you had the initial challenge, but I'm seeing only one person. Is it only one person that is with me in the class? Modibo. Hello, Modibo. Okay, I can see Abdul. Okay, I can see another person. No problem. Let's continue. Others are joining in. All right. So here is the. I said before we had the initial challenge that the last class we stopped at random access memory. And unfortunately, as I have seen in your WhatsApp chats, that the first two videos I uploaded actually did not upload completely. I think there was power outage that day. I think that was what stopped it from uploading completely. But I have uploaded a video this afternoon. That one should be there. You should be able to access that one and watch it. And I want to crave your indulgence, all of you. We are all on this together. So let's be patient and we learn. And the purpose of uploading the video is not just for those of you that are able to join in during the Zoom class, but I know that there are many of you out there who are not able to join in during the session, so that at any time they can access that video and watch. Please, I'd like all of you to help me tell your friends. Some of them don't even seem to access the WhatsApp forum. They don't seem to come on there to check what is happening. But if you have their phone numbers, you can let them know so that they don't miss out on everything. Remember, you paid your school fees and you shouldn't miss out. You should learn. Okay, so having said that, please always be on the watch out. I created that YouTube channel just for this purpose, so that nobody will be shortchanged as much as possible. Even when I hold a class and people are not able to join, I'll record it and then upload it. Is that okay by all of you? Okay, I take your head.
Yes, ma'am.
All right, good. So now we continue. The last time we stopped at random access memory, and I believe everyone should be able to discuss. If I should call all of you to discuss, tell me one or two things about RAM and ROM. You should be able to answer sufficiently. So we move on to measurement of memory. Now, whether RAM, whether ROM, whether that's the internal, the two forms of internal memory, or whether we are talking about external memory, that is our secondary storage. Memory is memory. We measure anything memory, anything storage is measured in bits. Bit is the basic unit of measurement. And this bit, BIT, is a contraction of two words, binary and digits. So as you can see in the slide, by the time you look at the first word, binary, pick the first alphabet, B. And then you go to the second word, digit, you pick the last two alphabets, IT. You get your bits, B, then IT, bits. Let me have a full screen. Okay. Now the bits, a bit represents a switch. Every one of us has a switch in our houses, even where you are. You have a switch. where on the wall, for example, where you switch on the light on and off. So a switch can be only in one of two states. A bit can never be, it can never be both on and off at the same time. It can never be a 0 and 1 at the same time. It can only be an on or an off, and a 0 or a 1 at any given time. So that is how a bit represents a switch. A switch, you can't switch a light on and off. A light, there's no bulb, no electric bulb that you can switch that will be off and on at the same time. So it's the same sense we use in representation here of this basic unit of measurement. Now, when you have bits, remember a bit can be a 0 or a 1. So, but you can have several bits, which means you can have several zeros. You can have several ones, okay? Now, when you have a group of bits, whether all of them zeros or all of them 111s, and you have a bit, a group of 8 of them, that is called a byte. So a byte is a group of 8 bits. And in measurement, or rather in storage, in your computer, the computer space that is needed to store one character is what a byte rather represents. Remember, I take it again, a bit represents either a 0 or a 1. It can represent both. But a byte represents 8 bits, 8 zeros, 8 ones, or a combination of 8 zeros and ones. When you have, you can have 4 zeros, 4 ones, you can have 111, 000, but once it is 8, it gives you a byte. And that gives you the amount of storage, the space the computer requires to store one character. Now, when we say one character, it is not just A, B, C, D. No, a character is anything that can be stored in a computer, anything that can take 1 byte of storage space. That is a character. So it can be alphabet A or B or C to Z. It can be a number. It can be symbols like comma, your comma. It can be a dot like your full stop. It can even be a space. You see, once you hit the keyboard, once you hit your computer keyboard, whatever is registered in the memory is taken as a character. So if you hit the space bar once, it is a character. And that once you have hit the space bar, that space is stored in 1 byte. So if you hit your space bar 20 times, then that means the computer is going to store those keystrokes 20 times. It will store them in 20 times 8 bytes of storage. That's the meaning. So I would like you to understand that very well. Okay, now there is a progression. I've just given you that, okay, if you strike your computer, the space bar 20 times, you have, sorry, if you have 20 times 8 bytes, and whatever it gives you will be your measurement of storage for those 20 times that you hit your keyboard. Now, in the same way, when you type something, you can either type a word that is like come is a word, go is a word, bring is a word. You can type a whole sentence. You can type plenty numbers at the same time. So when you type plenty things, remember each of the stroke of keyboard, if you type A, if it is come, for example, your C will be stored in 8 bytes. The O will take another 8 bytes. The M takes another 8 bytes, and the E takes another 8 bytes. So that means 8 times 4. And that's about how many? I think 32, right? 8 times 4 is what, students?
Yes, my 32 one.
32 bytes. I want to be sure you are with me. Okay. So that's the 32 bytes just for the word come. Now, imagine a whole sentence. Imagine one page, one full page of documents. Imagine a document of 60 or 100 pages. Now, that gives you you're able to understand when you have a file and it tells you the file is so kilobytes, you'll be able to understand that, yes, because there's a lot that's been stored in that file. Somebody there, please unmute yourself. There's noise. Thank you. Computers combine bytes to represent large numbers. That's what I was trying to explain. Whatever is represented when it's large, whether large numbers or symbols, characters, once there are many like that, plenty things to store. What computers do is to combine bytes. I've given you an example of 32 bytes and so on. So you have, when it gets up to 1,000 bytes, hey, somebody there, unmute. I will unmute all of you. I will mute everybody if somebody does not mute himself or herself.
Raphael, please mute yourself.
That noise should stop. Please mute yourself. Thank you. Thank you. We don't have, NEPA takes light now. That will be the end of this class. So let's run as fast as we can. Okay, so that's how you have kilobytes. A kilobyte is 1,000 bytes. So when you have all these 8 bytes and it gets up to 1,000, you have 1 kilobyte. But in computer, we don't actually have 1,000 bytes. What we have is 1,024 because there's no how you will multiply 8 by 8 that it will give you 1,000 on the dot. Next, you have megabytes, you have terabytes, you have kilobytes, you have all of them like that in that progression. And it goes in the power of 2. 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. So you have the digits. Then you have 2 raised to power 4, that's 4 bits. 4 bits, you have 2 raised to power 3, that's your 8 bits, which is a byte. You have 2 raised to power 3, that's 16 bits, on and on like that, and which is 16 bits, of course, is 2 bytes. Okay, now size of memory is measured by the number of bytes available. So if you want to know how big or how large is your memory, how large is RAM, how large is the ROM, of course, like I told all of us earlier in the other day's class, we don't bother ourselves about ROM. ROM is not accessible to users. ROM stores very delicate software, very delicate material that are not open, are not accessible to you and I, because those materials those software that are so delicate that once they are tampered with, a lot of things will go wrong, like your BIOS, the basic input-output system, which helps your system to boot anytime you switch on. So that's why we don't bother so much about the size of ROM, okay? But we do bother about the size of RAM, because I remember that I said that RAM is the working space. That's the space, the memory space that is available to you anytime you have anything to do on your machine. The moment your system finishes booting, RAM is opened for you to use. It's like your workspace, your work environment. So everything you are doing on that computer at that given time that your system is on, you do all of them in RAM. But remember, RAM is temporary. RAM is for temporary storage. You only use it to, while you work. The moment you are done with your work and you switch off your system, RAM goes empty. everything that you were seeing that were in RAM, they all go. And that is why we save our work on external storage devices. We'll get to that later. But just to let you know, the size of memory is measured by the number of bytes available. So the next slide, we look at representation of symbols. Please don't be confused by the word symbols. We are saying the same thing. It's either a character. So you can equally say representation of characters. Okay, symbols or characters are represented according to patterns of bits. And there are two most commonly used patterns. One is the EBCDIC, that's EBCDIC, Extended Binary Coded Decimal Interchange Code. Extended Binary Coded Decimal Interchange Code. The other one is the ASCII. ASCII is American Standard Code for Information Interchange. It's good for you to know these are acronyms. So if you are able, try and know their meaning in case you see something like this in exam. So don't just gloss over it and move on. Now, both of them use 8 bits. And that is why they are the most commonly used. That's part of why they are most commonly used. They use 8 bits. That is 1 byte to represent a symbol. So now let's see example. The character, the pattern to be used. So the character here is 1. Remember I said in the other slide when I explained that a character can be a number, it can be an alphabet, it can be any other symbol like your comma, your full stop, your equal to, a bracket, a minus, a plus, and all that. Anything at all, even a space. So now, the character here is 1. And look at, if it is EBCDIC you are using to represent a 1, it takes 4 ones, 3 zeros, and a 1. And if it is ASCII, the 1 as a character will be represented as 2 zeros, 2 ones, 3 zeros, and a 1. So you can go through all of them. But there's something I want us to see quickly. Look at the character, the character A in capital letter, uppercase A. Uppercase A in EBCDIC is represented by this, is a byte containing two ones, followed by 5 zeros, and then followed by a 1. Oh dear. And then in ASCII, it is a 0, 1, 0, 0, 0, 0, 5 zeros, and a 1. Now look at the same A in small letter, that's lowercase a, compare it with uppercase A. Look at the huge difference. This is 1, 6 zeros, and a 1 in EBCDIC. But in ASCII, it is a 0, 2 ones, 4 zeros, and a 1. The same with, if you look at the small letter B, the lowercase b, compared with the uppercase B, you see the difference. So this is to show you that when you type in uppercase, the representation in uppercase will be different from the representation in lowercase. But it's not for you to bother your head about. When you are typing, you don't bother how they are represented inside, but this is for us because we are studying the science of computer, okay? Because this is the science of it. A user doesn't bother himself about how these things are stored, but you and I need to know because we are here as computer scientists or computer engineers. All right. Memory and storage sizes. Okay, now I want us to take a little look at this table. There are terms that are used from the former explanation I gave. You have the bits. It is abbreviated as a small letter b, lowercase b. And it is approximately, in memory size, it is approximately a 0 or a 1. Remember, a bit cannot assume the two at the same time. A bit is either a 0 or a 1. The exact memory amount is binary digit. Remember how it is binary digits. Remember that the word bits is actually coined from these two words. These two words, remember, we have done that in the previous slide. Another term you hear about in computer science is the nibble. When in terms of storage, the nibble. The nibble is abbreviated as N. A nibble is simply 4 bits, 2 raised to power 2 bits, 2 raised to power 2, 4 bits, and it's 4 binary digits. A byte, which we have talked so much about, is abbreviated with capital B, and it is 8 bits, approximately 8 binary digits, and approximate pages of text that it can store inside the computer is just 1 character, one character. Then you have the progression now, a kilobyte, as I told you, when it becomes 1,000 bytes. And I did tell you that you don't actually have 1,000. If you are writing it, you don't have 1000, that's 1,000. But what you will have is 1,024 bytes, which is what you have, the exact amount, the exact memory amount is 1,024 bytes. And the abbreviation is KB in capital, KB, or simply K. So if you see it written in book, you can see K, okay? Maybe you see 2K or 2KB, that's talking about kilobytes. And what does it represent? In the computer system, it will actually store half a page of text, half a page. Just imagine you are using Microsoft Word and you type half a page. That your half page document will be approximately 1 kilobyte of data stored in memory. Then the next one is megabytes, MB, abbreviated uppercase letter MB or capital letter MB, and it is 1 million bytes. And you can see it's not exactly 1 million. So if you follow the progression I told you before, that everything is actually in the power of 2 raised to power 2, 2 raised to power 2 raised to whatever power. So if you convert this 1,048,576 bytes, this will give you 1 megabyte, or approximately 1,024 kilobytes. Now, how much storage, how much data will this million bytes store? 500 pages, 500 pages of, no, not 500 pages of text, but on a page of text, you can have 500 pages of text, would maybe too much, but just take it as it's there. This one is half a page, and this one is approximately 500. Then you have the gigabytes. A gigabyte is 1 billion bytes, 1 billion bytes. And this is the exact memory amount, 1,073,741,824 bytes. And it will store approximately 500,000 pages of text Then you have a terabyte, TB, which is 1 trillion bytes. And again, you have the breakdown here. And this one will store how many? Approximately how many pages of text? Students, can I hear you?
Yes, ma'am.
So how many pages of text will this one store? 1 terabyte. Come on now, you did mathematics in secondary school. Start from the back. Where my arrow is the first 1,000. This one is 1,000,000. So this will give you 500 million pages of text. All right. So let's move on. Okay, so let's go on to storage devices. Now, what we are looking at here now is no more the internal memory. This is external memory. Okay, so like it's my pattern, I read some of these things so that when you are reading, you will flow, you will understand. The media on which data, instructions, and pieces of information are kept for further use is what we call storage devices. A storage device is a medium. That is one storage device is a medium. But now we are looking at it in plural form. Storage devices are the media on which data, instructions, and pieces of information are kept for further use. The catchy word here is further use. Why further use? Okay, now let's read the next sentence. You understand better. Secondary storage is memory outside the CPU and internal memory. It is mostly needed because of limited amount of internal memory, that's one, and because of volatility of RAM. I believe you all understand. You can still remember what it means for RAM to be volatile. Yes? Do you remember? Hello, nobody is there?
Hello, ma. I can't get you.
I said, do you remember what it means for RAM to be volatile?
It can easily lose data.
It can easily lose data. Very good. So now, I started from the first sentence that storage devices are media on which data, instructions, and pieces of information are kept for further use. And I told you the catchy word here is further use. So now, why do we need a secondary storage? That is these storage devices. Why don't we just make do with our RAM and ROM? Number one, we've seen that ROM is not for our daily use. ROM is for some specific, special software that the computer needs to run adequately, like our BIOS. Now, and about BIOS operating system also. Now, the second reason is because on this second slide, you can see inside the CPU, which we saw the other day, you have the processor, and then you have the control unit, you have the ALU, then you have the memory, the internal memory. And I explained the main reason why the internal memory is there is to temporarily hold data and instructions while the processor is processing them. Okay, so that for speed, to be able to make for speed. Okay, now the internal memory itself, that RAM, is usually not large. You can never have a large enough RAM. No. The RAM is usually small enough to allow you do what you can have 4 gigabytes, where maybe you can have 4 gig, 8 gig, and so on. But if you are looking for large storage space, not RAM, and where you have a lot of data to store, you need a secondary storage. So that's the second reason. RAM is limited RAM size is always limited. That's our first reason why we need a secondary storage devices. And then second reason is that RAM is volatile. Like Aliu Rafa just told us, RAM can easily lose data. We've already also agreed that storage capacity is measured in bytes and in the progression of kilobytes, megabytes, gigabytes, terabytes, petabytes, and so on. We've agreed to that, whether it's RAM or external memory. This measurement is the same. Now, examples of these storage devices are given here. You have magnetic tapes, disk, you have Blu-ray disc, compact disc, like your CDs, whether they are CD writes, CD readable, CD read writes, and flash disk, digital versatile disk, DVDs, and then the hard disk that we all have in our systems. And the hard disk can be internal or external. You need an external hard disk when you do a lot of work and you want to keep it safe. You want to have some saved. So you can store some of that work or a copy on the external and keep away from your computer, so that in case they steal your laptop, for example, you will not cry. You know that I have everything on my external disk. So anytime you get a new computer, you just, load them back onto the hard disk of the new computer. All right. Now, having talked about storage, their measurements, and then those types we just discussed, well, let's look at how data is organized on storage. How is data organized on storage? The first thing we'll look at, I would like us to take note of the words file, record, fields, and of course, variable. So let's go. Information is stored as file under a file name. So when you want to store your file, you save. You save that file and then you give it a name. And when you are giving your file a name, you give it a name that you can easily remember, or you write that file name down somewhere that you can always make reference to. Every file is either a program file or a data file. It's either a program file or a data file. Now, data files, of course, can be your document files, like maybe you write a letter and things like that. Then program files are software, even your game that you play on your system is stored as a file, as a program file on the system, because that game is powered by some program. A file is made up of records. Records are subdivided into fields. A record length can be fixed or variable. Files are accessible either through direct access or sequential access. Direct access like your disk, or by sequential access. Files are stored in folders or directories. Now, this may sound okay, a lot of grammar. I'll explain briefly. Now, we have understood point 1 and 2. Now, point 3 says a file is made up of records. I want to use something that an example that will be easy for you to understand. Okay, assuming I want to create a file of students. I create this file and I call it group 2, DCS group 2 students. Now, inside that file, I'm going to have a record of each and every one of you. And your record will contain field. I'm breaking down this, so be very attentive. Inside the file, which I will save with the name Group 2, DCS126 Group 2 students, okay? Inside that file, I will have records of each and every one of you. So now I can see Modibo, I can see Abdullah Ibrahim, I can see this DCS 1060. When you put your name, I will see your name there. Now, your record will be made up of fields. And what are fields? A field is a breakdown of this record. Now, your record is everything about you as a student, everything about you that I want to capture and store in that file as an individual student. And some of the things which by compulsorily I should have will be your name, your surname. So if I pick your name and I divide your name into first name, surname, I'm having two fields already. The one field is surname field, the second field is name field. Now, if I have another field to know whether you're a boy or a girl, I'll have a gender field. So I have another field, gender. If I have another field that talks about your age, I can have a date of birth field, DOB, date of birth. That's another field. So far, I'm having 4 fields already. So I can continue to break down information about you in smaller bits like that. Each of those small bits of information about that person is a field. And when I put the fields together, I get a record of one person. So if I'm taking Abdullah Ibrahim as a record, now if Abdullahi maybe is the surname, Ibrahim is the first name, the gender, male, date of birth, well, whatever the date of birth. I can go on and say, okay, how many courses is this, the course title or field, course of study, computer science, that's a field, or computer engineering. So I can go on and on. States of origin, local government, and so those are fields that make up your record. Now, each record length can be fixed or variable. In computer storage, the person who is, this is more of database management now. The person who is working behind the scene to organize our data, how the records are stored, will either set the records to be, the record length to be fixed. Now, if it is fixed, I'm still using Abdullahi as example. Abdullahi's first name, ABDU, that's 4, LL6, A7, H, 9. Abdullahi is 9 characters. So if the person is setting surname as 9 characters, that means if anybody's surname is longer than 9 characters, that name will not enter into that record, into that field. That's what it means by having fixed length. But if it is left to be variable, that means the Abdullahi Kotangora can come into that one field, as long as the person leaves it. So it will be vary. Some people's surname will just be 3-letter word. Meanwhile, somebody else's surname will be 15-letter word, and it will all be stored. That's the meaning of record length being fixed or variable. Now, accessibility of files, either through direct access or sequential access. Now, if it is your disk, you just slot in your disk, or you are working on your hard disk, you just enter the file name and directly the file name is fetched for you. But where it is sequential, that a sequential access means that you have some things stored already. Now, nothing will be jumped. If you are looking for anything, it must pass. If what you are looking for is, let's say, number 10 in the storage, It must have to pass number 1, 2, 3, 4, 5, 6, 7, 8, 9 before it to get to number 10. So sequential access is all the time is slower than direct access. Direct access, of course, is faster. Now, files are stored in folders and directories. This is organization. If you have files that are program files, you can store them together. All your program, all the software you have written, you open a folder or a directory and store them there. Then you create another directory or folder for anything that is music. You put them in music directory or music folder. Then you can create another folder or directory for anything that is video. You people like watching video a lot. You store your videos in one folder. In that way, your memory, your computer memory or storage will not be scattered. You know, it shows that even you yourself, you are organized. When you are looking for video, you know where to go and look for it. You know the video folder. When you are looking for music, you know that you have a music folder. When you are looking for software that you have, maybe your assignments or maybe your homework, you know you created a folder for your assignments. You just go there and pick them. So that is what that is all about. All right, we move on to communication units. If you remember where we are coming from, I showed you the block diagram of the computer system where we saw the input units made up of input devices. Then we saw the processing units made up of the control units, that's the processor, the control units, the arithmetic logic units, and the internal memory. Then we saw the output units made up of output devices. Next, we have seen also the storage units made up of our storage devices like our hard disk, flash, and CD-ROMs, and so on. Now, the last unit that we haven't discussed is the communication unit. All that we've been discussing so far is the hardware, the computer hardware, okay? So this is the last bit on computer hardware. Okay, communication is a sharing of information or messages between two entities. And then in order to share information, in order to share messages between two entities, you must have a device. So communication devices enable computers and users to connect to a network in order to share information. Communication devices enable computers and users to connect to a network in order to share information. And for this to take place, there must be these two infrastructure. There must be these two. You have a network interface card, NIC. There must be a NIC. The computer must have a network interface card. The computer must have a modem. A modem. These two must be available for there to be adequate communication between two entities. So let's look at the NIC, the network interface card. A NIC or network interface card is the device that enables a workstation to connect to the network and communicate with other computers. It's a device that enables a workstation to connect to the network and communicate with other computers. That is a NIC. It is a device that enables a workstation to connect to the network and communicate with other computers. I don't want you to be confused. In one of the videos I recorded earlier, I explained what a workstation is. A workstation is a computer. It's a computer. It can be a full computer with a system unit, keyboard, mouse, everything. It can also be, particularly if it is a terminal, like the type used by mini computers. It may not have a system unit of its own. It may just be a terminal web that connects, all of them will connect to the mini computer. The mini computer will be their system unit where the processing will be done. And then the workstations, the terminals will just be a keyboard and the VDU, that's a monitor. So when we say workstation, we're just talking of a computer where a human being is sitting. You know, you're sitting, that's your workstation at that time. So when a workstation is able to connect to the network in order to communicate with other computers, there must be a network interface card to enable that connection. If you are working on your computer and you are able to connect to the network, that means your computer has a device called the network interface card. All right, the specification of any particular NIC should meet the requirements of the workstation and the network on which it is to be used. Now, examples of network interface cards are adapter card, NICs, PC card NICs, USB NICs, wireless NICs. I'm sure you understand the NICs are just the same thing we are saying. Adapter card network interface cards, PC card network interface cards, USB network interface cards, wireless network interface cards, and so on. And here you have an example. This is actually where the connector, okay, to the NIC here. Now we look at modem. What is a modem? A modem is a communication device that derives its name from its function as a modulator, demodulator. Now, before I go into talking about signals, what modulator, demodulator, what it simply means is change. A modulator, to modulate means to change from one state to another, okay? So have that at the back of your mind so that you don't be confused at all. Now, what does it do? The function is first to modulate. So as a modulator, it modulates analog signals into digital signals at the transmitting end. Okay, assuming that where I am sitting in front of my computer, I'm the one transmitting, I am the one sending. I want to send some information across the network. Okay, so when I send, the modulator on my system will change the signals into digital signals. Once I send, it will change those signals into digital signals for the computer to carry. Remember that the computer is a digital system. The computer is a digital system. It's not an analog system. So if I am talking now, as I am talking into my microphone, now what is happening is that the modulator picks from the airwave, it picks my voice, the sound, and then modulates it, changes it into digital form. And then my computer carries it. Now, when this transmission gets to your end where you are right now, the modulator will now function as a demodulator on your own end. At your end there, it functions as a demodulator. The digital signal, remember, my voice My voice is an analog. Every human voice, anything we say goes into the air in wave-like form as analog signals. And that is what is entering into this microphone, into my computer. But the modulator changes this analog signal that it is receiving, that's my voice, it changes it into digital signal. So inside the computer, my computer does the transformation via the modulator and then sends the signal across to you where you are. Now, when it gets to the computer where you are, you don't know what you and I, we don't need to bother ourselves about this thing, but these devices are doing their work. There is a modem in the system where you are also using, because we are all connected over a network. So the modem now forms a demodulator. It will demodulate what my system has sent over the network. It will change it now from a digital signal back into an analog signal. That is why you are able to hear my voice. I'm speaking right in my office, but wherever you are able to hear my voice, because there is a modem in my computer, and there is a modem in your computer. At my side, my end, the transmitting end, I am the one transmitting. My modem serves as a modulator at this point. And then when it gets to you, the modem in your own system will serve as a demodulator. Is that clear? I want to hear everybody tell me it's clear.
Yes, ma, it's clear, ma.
Okay, good. Now.
Yes, ma, it's clear.
Okay, thank you. All right. Now the module. Oh, okay. Thank you. So let's continue now. A modem may be internal or external to the computer. Now, all that I've been saying, my modem is built into my system. Maybe where you are, your modem is built in, but you might get some places where you see a modem standing or sitting next to the computer. It will still serve the same purpose. Okay, so whether it's internal modem or external modem, it will still serve the purpose of modulator, demodulator. So internal modems are adapter card modem, which exists as an adapter card that connects to a computer's bus. External modems are simple installations, they are slow in transmission. The internal modems are faster than the external modems. That's what we want you to know. And you have them, example, you have serial port modem, PC card modem, and USB modem. These are external modems. Oh, come on, sorry. Okay, so this slide is an assignment, students. Please, I would like all of you to do this assignment. I want to get a feedback from you. The essence is you to make sure you read and at least give back a little to show that you are reading and you are understanding. And I want you to write. This is not a CBT thing. So I want you to write the answers and submit. I would have said submit online, but no. Since I know now that a number of you are still around, write it and submit in your own handwriting. I don't want you to type, and I don't want you people to copy. Please don't copy yourselves. When you copy, you don't help yourself. But when you do it yourself, if you are challenged over any of the questions, go and read again. You will understand. There are textbooks. If the manual is not enough, read. Go to the library, pick up books, read. It's very simple. The questions are simple. So do the assignments and submit by next week, Wednesday. You know, our time, our regular time on the timetable is Wednesday, 11 a.m. But because of light situation and network, that's why I chose to do this on Thursdays when a lot of people have gone away from the office and network is more stable. So let's do it and submit Wednesday. Use our, if you are too busy, which I know you are not, use our time to finish it up and submit. Wednesday, 12 o'clock, I should get your assignments. Thank you. And those of you who are far away, still do your own, write it. You find a way to send it. Let's move on. So we are done with, yes? Any question?
Are we going to write it in a paper, or we are going to buy a small note?
I'm tired of you people buying notes. If you buy a note, it's good. But if you buy it, make sure you come and collect it. Over time, when students buy notebook, when they submit, they forget to come and take their notebooks. It's okay by me if you use a notebook. So you write and then submit. When I'm done with it, I just want to be sure you people do that assignment. You come and pick your notebooks, but otherwise you can use a good foolscap sheet. Don't use this fake foolscap that when you touch it, it will start tearing. Is that okay?
Yes, ma'am.
All right. Okay. Now we are moving on to software. We are moving on to software. Enough of hardware now. So let's see how fast we can go before anything happens to this Zoom. Please, students, wherever we stop, because the system we are running is not a perfect system. It's either light goes off or network throws us out. So anyone that happens, don't worry, I will record what I'm recording. So we'll just, I hope I didn't pause this recording. Just please let me be sure. I hope I did not. I will record and then and send it to all of you. Make sure you get it. Okay. Okay, I think we are still recording. Okay, back to software. Everybody knows what a software is, but we'll just go through this to fulfill all that we need to do. Software, actually, we usually don't say a software. We just say software. Why? Because software is a group or a set of instructions or program written to perform a specific task. It is a series of instructions that tells the hardware of a computer how to perform tasks. It is a set of instructions. And now let's come back, break it down a little. A set of instructions is called a program. A program is a set of instructions. Software comes stored on various storage media. Before I go down there, I just wanted to pick something. A set of instructions is often called a program. Now, you can also have a set of programs, where a set of programs are software or a suite of software. But basically, software denotes or connotes the instructions that run the computer hardware, the instructions that tell the computer what to do and how to do the work it needs to do. Now, software comes stored on various storage media. Software must be installed. There are two types of computer software. You have the system software and the application software. The system software are programs designed to control the hardware. The system software are programs designed to control the hardware. Example is the operating system. Another example is utility programs. Now, under your operating system, that's OS, you have different operating systems. You have the Microsoft Windows with different versions, version 10 and all of that. You have Mac operating system, you have Unix, you have Linux, and so many versions of them. Then you have utility programs like diagnostic software, your antivirus software is a utility program. They are all there. And then application software are designed for the user to perform specific tasks like your Microsoft Word, your spreadsheets, database, and so many others out there. So any software that is designed for you as a user to perform one task or the other is an application software. It can be an engineering software. It can be an agricultural software. It can be a medical software, whatever. The main thing is that it is designed for the user to help one human being or the other do his or her work, perform one task or the other. That's an application software. Okay. These are system software. Yes, I'm still sharing my screen. System software, okay. System software are programs. We have seen all of that. I don't need to go over it again. They are written to coordinate the operations of the computer system. It manages the hardware, the software, and data resources of the computer system. So a system software is a managerial software. It's a software, the kind of software that manages everything about the computer. It manages the hardware. It manages the application software. That's other software. That's your application software. And it also manages the data resources of the computer. It enables all-round communication between the hardware and users. For example, your operating system. When you boot your system, if your operating system is a system software, it helps you. It helps ensure there is communication between the CPU and all the other devices. So when your computer is booting, for example, if you are using a keyboard, I'm not talking about your laptop now. Maybe a keyboard, you have to attach the keyboard, connect the keyboard to the ports. Now, if there's anything wrong with the keyboard, during the time of booting, when it is bootstrapping, the operating system will halt and inform you, give you a message, an error message that there is a keyboard error. Why? Because it's not the operating system at that time is unable to establish communication between your keyboard and the CPU. So these are the things the operating system does. It makes sure that all the devices in the computer are communicating. They can communicate with the CPU and with themselves. Okay. All computers require an operating system. Actually, without an operating system, no computer will actually work. Every computer needs an operating system. It's the backbone of every work that the computer does. The OS tells the computer how to interact with the user and its own devices, and common examples are given here. Oh, I hope our time is not on. Okay. Next, let's look at another one, utility program, which is also a system software. It is a program that performs a task that is not typically handled by the operating system. It is also referred to as system support programs. So the work of utility program is to support the system, okay? Because they actually enhance the functionality of the operating system. They assist the computer in operating various hardware components attached to the program. Some utility programs, such as drivers. A lot of times you will hear driver, printer driver, this one driver. Those are simply utility programs that make sure that the printer is working properly. So these utility programs usually come with the hardware, e.g. printer, and must be loaded in order for proper operation of the device. Some of the major categories of utilities or utility programs are file defragmentation, data compression, backup, antivirus, screensaver. These are just examples of what they do, what utility programs do. File defragmentation, it can break a file into smaller fragments, and it's actually helpful in storing of some files. Maybe the file is too large, it can defragment. And sometimes your system has one issue or the other. The best way to solve that system problem is to defragment your files, because they are so bulky, and the bulkiness now is causing problem for the hardware. So it can be defragmented. You sometime of course you want to, like I wanted to upload the video you people say you didn't see. I initially wanted to upload it on WhatsApp, but it was just too large. And that day, before I could know it, a lot of things happened. I couldn't compress. I needed to compress it. If I had compressed that file, I'll be able to upload it. Then when you people receive it, then you unzip and then be able to see. But I couldn't do that because of so many factors that worked against the task that day. One was light power outage. Then you back up your files, antivirus. All of us know the problem of viruses on our systems. Okay, can we move on? Okay.
No, ma, we are not hearing you, ma.
You are not hearing me?
Now we are hearing, ma.
Okay, can you still see the screen?
Yes, ma.
Okay, fine. Okay, so we want to look quickly at the purposes and functions of operating system. Two major purposes. One, to provide user-friendly interface, and two, to manage the resources of your computer efficiently. Now, there are two user two user-friendly interfaces. You have the CLI and the GUI. CLI means command line interface. Command line, CL, command line interface. And GUI means graphic user interface. Out of these two interfaces, the GUI, or simply called the GUI, is actually the most user-friendly. Now, command line interfaces are provided by operating systems like disk operating system, Linux operating system. I think Unix operating system also does provide CLI. There you just have a line where you type in the command and the computer will execute your command, and you need to know the commands. But the GUI is the one that Windows operating system has provided for us. You don't need to know the command that the computer is going to obey, but things are made a lot easier as icons, images, graphical images, where you just click and something happens. And you say, I clicked this and something happened. That your clicking is actually sending a command. That's the user friendliness of GUI, the command line interface called GUI, graphical user interface. So the other purpose of operating system, I said, is to manage the resources of the computer efficiently. And these resources are input and output devices, memory, and processor. I already explained how one of it is make sure that keyboard is working. Okay, you want to print something, is the operating system will check that there is a printer. Sometimes to tell you that you can't see any printer. So what do? Check whether the printer is connected. If it is connected and it is not working, check. Sometimes it will tell you printer out of paper. All is being handled by the operating system. Now the functions are listed here. Functions of operating system. Number one, management functions. Can remove this S, please. Management function.
This thing we are not seeing it, the slide.
Oh, you are not seeing the slide?
Yes, you haven't shared it.
Oh my God, sorry. Can you see it now? Hello? Can you see it now?
Yes, ma'am.
Okay. So maybe we'll just continue with, let me still make it bolder. Okay. These are all the things I explained so far, the CLI and the GUI. I don't need to explain again. You already heard me. Okay. Now the functions of operating system. We look at the management function. The operating system manages the input output, and it manages job management and printing. What is job management? You send you give a task to the computer, it does it for you, and then you want to print. Now, when you want to print, you may want to print more than 2 files at the same time. Maybe you are sending 3 files to the printer. Now, job management now, the printer, the operating system will make a queue. Just the way that if you are going to withdraw money from your ATM, you'll be expected to queue up. So in the same way, the operating system will form a queue for these jobs you want to print. Those documents are now called jobs. So it's to manage properly, it to put them in queue. The first one that you send to print, followed by the second one, followed by the third one, like that. Now, so if the first one finishes printing, then the second one will be sent, will be activated to print, and then like that until the jobs, all of them get printed. Well, for now, you may not understand that very well until you get to use send jobs like that will be on queue. And there are times that you may send a document to print, Then something goes wrong and that document has been put on queue. And then maybe out of frustration, because something went wrong, you just go away. That document is still on queue. When you come back the next day and you send another job to print, you will discover that that one you send that day will not be the first to print. What will come out will be the one that was already placed in the queue. That one will come out. Sometimes it has happened to a lot of us. They say, oh, what is this? I thought I canceled this job. So because maybe light went off, you didn't cancel, and that job remained on queue. And when you return, it will just pick up from where it stopped. That's job management and printing. Then file and data management. It manages your file. I've explained how you create your folders, how you store your file, your data records and all of that, and you create folder or directories to store your files, give the file a name. All of that is handled by the operating system. And then conflict resolution. One will wonder, conflict, are they quarreling? No, they are not quarreling, but there are times because of our human impatience, we send a lot of instructions, jobs to the computer, and all of them are received. They are handled by the operating system. So by the time one has come, another one is coming, another one is coming. A lot of times the operating system seem to be as if it's getting confused. No. So what it now does is to resolve the conflict. This one is saying, no, it is this work that needs to be, for example, this work needs the printer. Another job comes, it needs a printer, and it's just one printer. So there must be a way to resolve the conflict. And like I said earlier, the printer, the operating system will now resolve to batch them or put them in a queue so that there will be no conflict. You, after you go, like that, and everything works out fine. And all of this happens, like I have said earlier, users do not even know what's happening, except where it's a programming thing and you are the one doing your software and you are managing, you have to, debug and all of that. That's when you can have a real feel of most of these things that operating system does. So operating system does a lot. That's why without the operating system, your work computer will not even start. It won't boot. It will not bootstrap at all. And it will not be able to run any application software. So if you bring the best of application software and there's no operating system, you won't be able to do anything. It also manages the memory. It also manages resource and hardware. Okay. Now, the operating system uses interrupt requests, IRQs, to maintain organized communication with the CPU and other pieces of hardware. Each hardware device is controlled by a piece of software called a driver, which allows the operating system to activate and use the device. So your printer has a driver. Every of your hardware device is controlled by a driver. So just think of any device that is hardware. It has a driver. It has its own piece of software. And each of them allows the operating system to activate it and able to use the device. Okay, so now we move to the next slide. The next thing that the operating system does is to carry out basic services. The first function is management functions, under which we saw how it manages virtually anything hardware, everything, okay? And now the next thing here is basic services. The operating system manages all the other programs that run on the PC. To provide services to programs, it has to make system calls, requesting other hardware and software resources to perform tasks. In the last slide, I mentioned IRQ, interrupt requests. IRQ, interrupt requests. In large computer system environment, you find a lot of these interrupts, and the operating system does so many of this in the background. You are typing, for example, and while you are typing, maybe somebody comes to say, please help me print this document on Flash. Is one system that's going to do this work. Remember, one operating system is handling everything. Now you are typing. So you say, okay, just insert your Flash. The person inserts the Flash. Now at that point, you are going to place a request. You were already typing, and what you were typing was being assessed by the CPU, processed by the CPU. Now, when you place a request to print, that request, remember, that request comes in too as an input, and it is also going to be received by the CPU. So now the CPU is receiving two things at the same time. It's having two requests. One is this input you are typing, you are keying in from keyboard. Another one is this one that is coming in from the drive, your Flash drive. Okay. Now, when the two goes in, now what the operating system will do is to interrupt one. It has to interrupt something so that the printing can be done. So there will be a immediate urgent interruption. It will interrupt your typing that the CPU was receiving your input at that time. That one will be interrupted, and then the printing job will be, activated. So while the printing job is going on, then you are still typing. Now what you are typing is going into the system, but the operating system had halted something internally to enable the printing to proceed. So as that is done, that is interrupt request. It sends an interrupt request. Sorry, I may not be able to explain this perfectly, but in your operating system, you have a course, operating system. In your operating system course, all of this will be explained very well. You will see how the operating system handles interrupts, how it does scheduling, scheduling of requests and functions and all of that. You see, you will get to know more. But here, we are just scratching it on the surface in this particular course, just to prepare your mind that when you get to go deeper into what the operating system does, you will know that, oh, I know this, and it will come easier for you to understand. All right, so it's on that. Oh no, sorry. It's on that I had to, I pause on this to remember interrupt because of these services that the operating system provides. So when it interrupts a function or a routine, it can then request one hardware to perform one task or the other. In this case, maybe requesting the printer to handle a printing job while the keyboard is receiving input from the user. Another thing the OS does is to share information. It handles the sharing of information. For example, Windows enables programs to share information. You can create data in one program and use it again in other programs without recreating that particular data. Windows also provides the clipboard, which is a special area that stores data cut or copied from one document, so you can reuse it elsewhere. Now, what do we mean by this? When you want to copy something using Windows, you can copy. Copy means to make a duplicate, right? You can cut. You can cut, C-U-T. So cut means to move that thing from where it was to somewhere else. So when you cut or copy, that thing you have taken, you have cut or copied, will be kept on the clipboard. This is the clipboard. That's is operating system. Windows operating system provides a clipboard. So it will be pasted there until you now paste it where you want to take it to. That is where it says, so you can reuse it elsewhere. You can copy from one package, one application to another. You can copy something from Microsoft Word and go and paste it in Microsoft Excel, depending on what it is. So the operating system allows you to do all of this. Another beautiful work that the operating system does is multitasking. Multitasking is the capability of running multiple processes simultaneously. Through multitasking, you can do several chores at one time, such as printing a document while downloading a file from the internet. Now, I have given you one instance of multitasking. You are typing and you send a job to print. While that document is printing, you continue your typing. You know, you open the page where you were typing and you continue the typing. So that's multitasking. Now, another multitasking is this example given here, where you are printing a document while you are downloading a file. You are downloading a file from the internet. For goodness sake, you are not the one going to the cloud to bring the file down. Computer is doing it for you. So it goes, while it's fetching it from the internet, your printing work is going on. You can equally type even while the download is on. You know, you are doing that in the background, and then in the foreground, you are typing. You can even listen to music while you are doing one thing or the other. All these are multitasking, okay? Now, there are two types of multitasking. There is cooperative multitasking and preemptive multitasking. The cooperative multitasking is such that applications voluntarily cede time to one another. Cede, that is give, allow time to one another. They give time. They say, okay, no problem, I give you my time. So that's cooperative. The applications are cooperating with one another, okay? Now, scheduling scheme capability employed by Microsoft Windows prior to Windows 95 and Windows NT and Mac OS prior to Mac OS X. X means extended, enables multiple applications to be run simultaneously. So remember I said, when you do the course operating system, I can't remember the course code, either 208, I'm not sure now. When you do it, you will learn a lot on how this scheduling is done. So there's a scheduling scheme where the tasks are scheduled. The operating system will schedule the task, one task and the other, and multiple applications will be able to run simultaneously. Now, let me explain this further. You can open Microsoft Word. You are working on Microsoft Word. And then you realize that you need to do something. You need to go to Paint. You know, there's a software called Paint. You need to go to Paint and draw something. That thing you want to draw, you want it to be drawn in that Paint environment. And after it, you now import it or you copy it to put it in your Word. Now, you don't need to close down Microsoft Word in order to go to Paint. All you need to do is minimize the window of Microsoft Word and then open Microsoft Paint, the Paint program. Open it, minimize it also. So on your screen, you can have two applications running. They are both running at the same time, but one will be active at one time or the other. So if you go over to Paint to do your drawing, at that time, the application that is active on the screen is Paint, but Microsoft Word is sitting beside it. Okay, so when you now want to switch over to Microsoft, you can just copy what you've done in Paint, switch over to your Microsoft Word, paint it, and you continue. There are times I've had to open up to 5 applications on my screen, 5, and I just minimize them, small windows, because I know I'm going to be crossing from one to the other. That is an example of multitasking that we're talking about. All these are made possible by the operating system. Now, the last point here says, because a cooperatively multitask system relies on each process regularly giving up time to other processes on the system, one poorly designed program can consume all of the CPU time for itself or cause the whole system to hang. So now, for you, computer science students, computer engineering students, when you are designing a program, be careful to know that if your program is poorly designed, it can consume all of the CPU time. A program can sit in the CPU and just, where the CPU is there, you are multitasking. Some other programs require the CPU time, but one program just takes a large chunk of the CPU time. And sometimes, because the other programs are waiting, the system may hang. So when you design your program, please be careful to design your program properly. Let your program be well designed in terms of time management, what your program is doing. Like if you design a program that keeps calling on another program, keeps calling, it keeps calling one routine or the other, as if it will never end. Sometimes the program enters into a loop. A loop it just enters into a circle, keeps going and never stops. And if that happens, that program is taking up the whole of CPU time. And the system may get to a point to just hang. It's like, what is happening, So we need to be careful in designing our program, bearing this in mind. So let's look at this next one. We've seen cooperative. The next one is preemptive. Preemptive multitasking. Preemptive multitasking. Preemptive multitasking allows the computer system to guarantee more reliably each process a regular slice of operating time. Now, the grammar here is that preemptive means that the operating system shares the time. So it will guarantee a regular slice of operating system to individual applications that run on that system. So it also allows the system to deal rapidly with important external events like incoming data, which might require the immediate attention of one or another process. At any specific time, processes can be grouped into 2 categories. 1, those that are waiting for input or output, called I/O bound, input-output bound processes, and those that are fully utilizing the CPU. Those ones are called the CPU bound. So there are, in preemptive multitasking, 2 processes can be running at the same time. That's what multitasking is all about. But now, this one is preempting. It looks at the operating system looks at the processes and says, oh, this particular process, we need much of CPU time. This one, we need more of input output time. This one is more of input output. So now it will now share time. The one that we need more of CPU time, it will give it a slice of time so that it can, while it is doing using the CPU, these other ones that are input output bound will be using the input output devices. So that's how it does that sharing of time. And at the same time, it bears in mind that while a process is going on, there may be incoming data, something very important, external events. So it also makes room for such to give it attention. So preemptive multitasking is so wonderful. And all these are the things that the operating system, is able to do. Let's continue. Wow, my system seems to be crying. Oh. Sorry, I got muted. In preemptive systems, wow. In preemptive systems, the software will often poll or busy wait while waiting for requested input, such as disk input or network input. During this time, the system was not performing useful work. With the advent of interrupts and preemptive multitasking, IO-bound processes could be blocked or put on hold pending the arrival of the necessary data, allowing other processes to utilize the CPU. As the arrival of the requested data will generate an interrupt, blocked processes could be guaranteed a timely return to execution. Now I will explain this. We are still looking at preemptive systems, and I've explained how if the operating system is using preemptive multitasking, now what the software will do will be to poll. To poll is busy wait, put things on hold. Okay, it looks at this job require this time, this one will require this time. So it will now poll them, like kind of group them, and while waiting for a requested input. So if a program, if an application requires an input from a user, and that input is not coming in speedily, one thing that the computer hates to do is to waste time, waste CPU time. CPU time is too expensive to be wasted. So the operating system understands this. So it doesn't like CPU time wasted. So while there is this waiting, it's called busy wait. A program is waiting for some data to be fed by a user. What the operating system will quickly do is to give time, give it to another program or another package or task, another task or another process. I think the best word is process, another process that requires CPU. Because if there is a busy wait, the CPU will be idle. So now the operating system has looked at all the processes coming in, and and they say, oh, this particular process requires CPU. So CPU, continue, keep being busy while we wait for this data that one human being is to type, and that human being is wasting our time. So the CPU, that task is given to the CPU to do. So now during this time, when there is a busy wait, the system will not be performing useful work. That's the point here. But with the advent of interrupts and preemptive multitasking, I hope I'm not confusing you. In a usual circumstance, of what I just explained, the system will be waiting. And I said, that is one thing the operating system will not want. Hello? Hello?
Yes, ma'am.
Anything?
When are we ending the lecture?
I will end very soon. I know you're tired. We'll end soon. I'm trying to just get to slide 90, then I'll stop. All right? Okay, sorry. So
Okay, ma'am.
okay, thank you. Now, because of preemptive multitasking, I explained earlier, IO bound processes will be blocked. That process that requires inputs or some input or output will be blocked, or it will be put on hold to wait, pending when the data will arrive. So the process will now, other processes will be given to the CPU to work on. So that is the benefit of preemptive preemptive multitasking of the operating system. Now, as the arrival of the data will generate an interrupt, any block process will be guaranteed a return. So once that data that is requested for comes, the process that was blocked will now be given time to complete its execution. Okay. So this is where I wanted us to stop. Managing files. This is the operating system keeping track of all the files on each disk. Users can make file management easier by creating a hierarchical file system that includes folders and subfolders arranged in a logical order. All this you will get to know. The C is a hard disk drive C, and it is the root directory or the root folder. Your hard disk drive C is the root. Every folder emanates or comes from this, is created from the root. Imagine this as a big warehouse. Imagine this hard disk drive C as C:, that's how it is indicated when you write it. Imagine it as a big warehouse. Then imagine that big warehouse, you want to store things and you just don't want to throw things carelessly. You bring rice, you throw, you bring sugar, bag, you throw, you bring biscuit, you throw. If you do that, by the time you are looking for biscuits, maybe the sugar has fallen on top of the carton of biscuits and smashed it. You may lose some things, and also it will take a lot of time to retrieve what you can easily retrieve. So that's why organizing these managing files done by operating system is so crucial. So just imagine that big warehouse. Now, instead of carelessly dropping everything, you now come into the warehouse, you arrange, you create a corner, you label it, create a box, maybe a cupboard or cubicles, create cubicles in that warehouse. And each cubicle, you label them, and there is a door to each of them. So when you come in, you have your bags of rice, you know where to put them. When you have your bags of sugar, you know where to put them. When you are bringing spaghetti to keep, you know where to keep them. And the same way, when you want to retrieve, you won't be scattered, you won't be confused. You know exactly where you stored what you stored. And that is what all of this is all about. So we maybe next class we will either, if you have any question on this, we can take your questions, because we are going to next class be looking at the graphical user interface. But if you have any question on the order we've done today, you can get your questions together, we discuss them, or if you are still strong enough to ask your questions, you can ask now, and then we take I'll be able to answer. Yes.
I have a question.
Okay.
This command line interface, how does it really work?
Oh, command line interface. Can you imagine a black screen? Imagine your screen without anything, just black. And then on that black screen, you see just one small area. And then where it is usually written C:/ then brackets greater than used as the bracket. And then you see a cursor blinking there. That is how it looks like. It's not actually very lovely to look at, because it's a black screen. Now, when you want to use a command line interface, you must know the command what you want your computer to do. For example, if you want to save a file, whereas in graphical user interface, you just quickly, click save. Here, you don't click save. You type the command to save. Okay, you want to delete a file. You have to type a command to delete the file, del. You type del, then the file name. It's a lot. It's interesting. It's interesting for those who are critical minded. It's interesting, but it's not friendly. If you are lazy and you are not ready to find out what command to use, you will not like a command line interface, kind of operating system. But don't worry, I think in our next class, we'll be talking, we'll be looking at that, and maybe God willing, you should be able to do it in your lab. I don't think I'm teaching you people lab. I don't know if any of you that I'm in my lab group, my lecture group is also in my lab group. But you should be able to, but I'll find a way to get you to see how it works. Is that okay? Any other question?
Yes, it's okay, but that means this command line interface is just like a command prompt.
Yes, it's a prompt. It's a command prompt.
Okay.
And it gives you a command prompt.
Oh.
Okay, maybe ahead of that day, what I would like you to do, when you go to, okay, let me do something. I don't know if you still see this, if I do it. Okay, let me say what I want to tell you. When you go to, when you open your system, on your system, if you type, this is a command, run command. Let me see run. If you go to on your system, your menu, your start menu, you will see run, RUN. If you click that run, it will give you a small dialog box where it will say open what? If you type CMD is command, that's run command. Once you do that, it will open the command line. I don't know. Oh, you can't see, you cannot see because it's difficult for me to share it right now. But me, I'm seeing my command line. But if you're on a computer system, just try what I said. You will see your command line interface. You see the black screen. It will show you Microsoft Windows version, blah, 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 copyright, blah, 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 Microsoft Corporation, all rights reserved. Then D:/ or C:/user/ I'm using ICICT admin, then the command prompt, ready for command, ready for my instructions. So that's how it works. Any other question from any other person? Any other question? Are we still on? No other question. Okay, since there's no
Yes,
other.
no other question.
Okay, I want to thank you all for patiently staying to the end. And in fact, today I'm very happy. Out of all the days, this is the only day that NEPA, the light has stayed to the end. Network also has stayed, behaved well, didn't throw us out and many times. So thank God for today's class. So God helping us. This is recorded. I would, as I've promised, I would send it to you, and so that you tell your friends who couldn't join the class. I could see only, oh, I'm seeing some chats here. I don't know. Okay, question. Should we submit to the class captain? Yes, please submit to the class. Okay, it's okay. Okay, the YouTube video link is not available. Don't worry, I will upload it. Deadline for submission is next week, Wednesday. I think I've answered all the issues on the charts, okay? So we can call it a day. Thank you, students. God bless you. Bye, till next week. Please, I want to say I may do this more often. Maybe anytime we can do a video like this, put up. The earlier you get all of this in the comfort of your room, you can watch, and of course, pull your questions together where you don't understand, and then we can discuss. Is that okay? All right, so bye.
Yes, sir.
Okay. Bye. Thank you.